Hello everyone, in this video let's discuss about full wave rectifiers. If you are new to our channel, please subscribe for more engineering related concepts. So what full wave rectifier does is it rectifies both positive and negative halves of the given input waves. So it will rectify complete DC signal. So complete DC signal given as an input. So complete DC signal means both positive and negative half cycles. Now to build a full wave rectifiers, majorly we need three components. So let's discuss about the components. Whatever the theory I am writing right here, you just write in the exams, you will get full marks. So components are, first one is transformer. Here let's call this as P, this as S, means this is the primary coil of the transformer, this will be the secondary coil of the transformer. Next N1 and N2. N1 is the number of turns in the primary coil and N2 is the number of turns in the secondary coil. Next, let V1 be the voltage across the primary coil of the transformer and let V2 be the voltage across the secondary coil of the transformer. So voltage will be same between this and between this, because this full wave rectifier will be called as center tapped full wave rectifier. See, it is divided in two equal halves. The voltage will be same, that is the same voltage right here will be as same as the voltage right here, that is V2 and V2. So this will be same, and we have two diodes. Let's name it as D1 and D2. The second most important component to build full wave rectifier is diodes. The diode D1 is connected to load resistance RL. So it will be the third important component to build the full wave rectifier, that is load resistance RL. Load resistance. In the secondary half of the transformer, that is in the secondary coil, we have three terminals, 1, 2, 3. So total 1, 2, 3. Three terminals are there. So we will give when we give DC signal as an input, we will get the AC signal as the output. So AC signal versus time will be the graph that we must plot. So this full wave rectifier will act in two situations. Let's consider its working. So when positive half cycle is there and negative half cycle is there. First one is during positive half cycle. During positive half cycle. During positive half cycle of the input signal which has been given, the anode will be connected to positive. That is, at the secondary coil, the terminals polarity will change. That is plus, minus, plus, minus. So if you consider a diode, this part is called as anode and this part is called as cathode. When you connect anode to positive, then it will be forward biased. So the positive is connected to the anode of diode D1. Positive is connected to anode of diode D1, then D1 will become forward biased. When a diode will be forward biased, you will get the output voltage V0. In D2 situation, it is connected to negative. Negative means cathode. Therefore, D2 will become reverse biased. When there is reverse biased, there will be no output voltage waveform. Therefore, it will produce a positive half cycle wave as an output. This will be because of the forward biasing of D1. So D1 is responsible for rectifying this positive half cycle. Next, during the negative half cycle. During negative half cycle. During negative half cycle of the full wave rectifier circuit with the given input. So this is the negative half cycle. During negative half cycle, the polarity will change. That is minus, plus, minus, plus. Now see, diode D1 is connected to negative. Now the diode D1 is connected to negative. Therefore anode is connected to negative means it will be reverse biased condition. Therefore diode D1 is reverse biased. Since it is reverse biased, there is no output voltage formation. Next, D2. So D2 is connected to positive, that is positive is connected to the anode of the D2. Therefore D2 will be forward biased. When it will be forward biased, there will be conduction of current. Due to the current, there will be output voltage, that is wave formation. So the negative half of the input signal is rectified by diode D2. So D2 is responsible for this. So D2. So this like only both positive half cycle and negative half cycle will be rectified. Positive half cycle because of diode D1 and negative half cycle because of diode D2. So this like the full cycle, that is positive and negative half cycles will be rectified in full wave rectifiers. Now let's discuss about some important formulas in this full wave rectifier concept. So first one is V1. What is V1? Voltage 1. The voltage across the primary coil of the transformer. V1 is equal to Vm sin theta. What is Vm? Vm is the maximum voltage. Next, V2. So the V2 is N2 divided by N1 into V1. So V1 is the source voltage, N2 is the number of turns in the secondary coil, and N1 is the number of turns in the primary coil. If N1 is greater than N2, then we will call the transformer as step down transformer. Then we will call the transformer as step down transformer. If number of coils of secondary coil is greater than primary coil, that is N2 greater than N1, means the transformer will be step up transformer. So the next formula is due to the forward biasing of the some diodes. Here D1 is forward bias, during negative half cycle D2 is forward bias. So because of the forward biasing, the current will be formed. The current I will be formed. What is the formula? I is equal to Im sin theta. What is Im? Im is the maximum current. Next, what is the formula of Im? Im is equal to Vm. What is Vm? Maximum voltage divided by RL plus 2RF. So what is RF? RL is load resistance. RF is the forward resistance. Because of forward biasing of the diode, there will be small resistance offered by the process. So it will be called as RF. It will be of minute size. Next, let's discuss about some characteristics of the full wave rectifier. Characteristics. So the first characteristic is efficiency. So when we consider efficiency, it will be of output power by input power. So what will be the efficiency of full wave rectifier? It will be 81.2%. Next, ripple factor. So the ripple factor of the full wave rectifier is 0.482. So that is less than the half wave rectifier. Ripple factor is the AC component present in the rectified output. AC component present in the rectified output. Hope you understood the concept of full wave rectifiers. If you have any doubt, please comment below. If you like the video, don't forget to subscribe. Thank you.